Hello everybody, my name is Craig Bennett and I'm the founder and owner of Tech Reviews and Help, and today I am going to talk about orbital mechanics, and I'm going to talk about particularly zero lift turns. Also, this is known as gravity turns. Now, as you may notice in the background, I am showing off Kerbal Space Program. This is important because you can use this in the actual game. You can also use this in real life, obviously. Now, as far as things goes, I do not have the math in front of me. A lot of the math is on the wiki. You can go there to look at a lot of the math. But, unfortunately, if you're going for real life, real school and whatnot, you might need to know all the math, and unfortunately I don't have that in front of me, so sorry about that. But if I find a math formulas, because I have them written down somewhere in one of my books, if I find a math formulas, and I'll try to put it in the description if I remember. But anyways, as far as things goes, the best way I can really describe the gravity turn and what it is, in the most basic way, is an airplane. An airplane, like a car, it has a horizontal velocity. Then you have a vertical velocity, as you see here on the screen, like a rocket. Well, if you're doing a vertical velocity like you're seeing here on the rocket, not so much right at this second, but if you're doing a vertical velocity, then you're not doing a gravity turn. If you're doing a horizontal velocity like your car, you're not doing a gravity turn. If you're doing both a vertical and a horizontal, you're doing a gravity turn, or you're using the gravity to help you out. Now, this is important for multiple reasons. The biggest is fuel. The second is landing, and I'll get into this in a little bit. But as far as things goes, the fuel, that's a huge thing with gravity turns, and that's why we used it in the space program for a long time, and we still use it today. Now, as far as gravity turns goes, as I said, if you're going toward a horizontal and a vertical velocity, the more horizontal you get, I'll say the more gravity turn, quote unquote, you're getting until you get a complete horizontal level. So it's important to note this, because in the background what you're seeing is three scenarios. First scenario is a rocket going straight up, or supposed to be going straight up, and has no gravity turn, or at least the least amount that I can give, as much as possible. That's important to note. So consider this being no gravity turn. It hits its apogee at 200k. It turns and it levels off when it gets 200k, so it circularizes the orbit. Then with the second one, it does near the maximum at 40k. It starts leveling out, and once its apogee hits 200k, it goes up and levels out the orbit completely. They all level out their orbit. The third one does a mixture between the two. It at 40k, it goes halfway between going straight vertical and straight horizontal. So at 200k, it levels out everything. I'll point out when the time comes, and you can kind of see that happening right now. But as far as things goes, as I said, the biggest thing with gravity turns is saving fuel. So as far as the space program goes, one thing you will notice on here is having no gravity turn is better than having a complete gravity turn, or almost a complete horizontal aspect. And having a some gravity turn and some vertical ascent, or like that 50%, is better than having no or a complete horizontal. So that's important to note, because depending on your angle of your horizontal and vertical axis, your X and Y axis, is dependent on your fuel efficiency, because depending on how much weight you have, how much drag you have, and not only that, how much orbit you're trying to get. For example, the height and whatnot is how much you really will save. So what's important to note is when you're doing a horizontal aspect, as you see here, it's pushing out the apogee and perigee to equal areas, or it's supposed to be. So as you see here, the apogee is at 200k, the perigee is not so much, but as the perigee goes out to 200k or tries to go to 200k, the sides of the walls of the orbit pushes out, and they try to push out to 200k. Now, if you're in a centric orbit, basically you're just looking at getting the thing to not hit the atmosphere of the planet or get too close to a planet in that aspect. So that's important to note, but anything else does not matter. Now, as far as the orbit goes, the more you get those walls out, the less work you have to do once you get to whatever your target is. So being here 200k. That's a common practice, is to actually launch something with some gravity turn, then when it hits a X target being 200k in this instance, it levels out or tries to level out. That's a very common practice. This doesn't always work for space planes. By space planes I mean any plane-like structure that takes off from a planet or moon into orbit and comes back. Now, the rest of this video in the background is going to be sped up by 400, which means four times normal speed. But as far, or 4 times whatever it's recorded. Now, as far as the next thing I'm going to talk about is landing and using gravity turns. Landing has, as far as using gravity turns, we've used this several times as far as the Apollo, Mars, and several other things. When we're putting a rover on Mars, we kind of use this. Apollo, we definitely use this. I don't really think we use this on Earth. I'm not 100% sure about that. But as far as things goes, with using gravity turns, as I said earlier, in more of a complicated sense, gravity turns is not about building or decreasing your speed. It's about changing your orbit. As you see here, we're changing the orbit, widening the walls of the orbit, which in return makes the orbit more stronger, so we won't hit anything, or makes it a bad orbit, which means we will hit something or be able to land on something. So if I was to flip this crap around and start burning the opposite direction, it will actually start decreasing the orbit and having it where this thing can actually land or pick a particular target within a given area and land. Now, as far as things goes, you can go then and keep burning and burning until you hit the ground and slowly descend. But that's controlling exactly where you want to land and also being gentle. But that's not really part of the gravity turn. The gravity turn is getting a general sense of where you want to land and picking your exact area you're going to land by using a gravity turn. Now it's here you're seeing me put into the autopilot 50%. Before you probably saw, and I'll bring it back up. Before you saw that the doing no gravity turn, we got more fuel than doing a pretty much 100% gravity turn by doing almost 100% horizontal after 40. Now again, this is sped up 400, and unfortunately I can't speed up any faster. But as far as things goes, what we're going to see is we're going to save the most amount of fuel this go around. Again, I'm going to show you that again after I show the fuel here, which is pretty quickly. As far as the modifications that I'm using for this video for Kerbal Space Program 0.23, I believe, is MechJab, and you can see the version right there on the right side. Now you see we're building up both horizontally and vertically. We're turning the stuff at an angle, and eventually it's just going to level out at 200K. Now, as far as this goes, it's only a couple more seconds until I shut the fuel, and we're going to be completely leveled out. And in a second or two, we start leveling out our orbit to circularize it into 200K. Now, as far as the looks, I got Universal Replacer and some other program in the background as far as showing the planet and the skybox around the solar system. And we achieved 200K. Now going back to normal speed, we can see here that the fuel is at around 900, let's just say, for the liquid fuel, and let's check the other ones. For the virtual horizontal, we got 700ish, and then the no gravity turn we got, or just about no gravity turn, is about 800ish. And that's important to note because the basically what this shows is having no gravity turn is somewhat better than having complete gravity turn. This is give or take your spacecraft, the weight, the thrust ratio and whatnot, but having a mixture between a vertical and a horizontal velocity somewhere in the middle might be better off. I found with most craft in Kerbal Space Program, you're looking at around a 40 to 60%. In real life, you're looking at around a 80% vertical velocity and a 20% horizontal, and that's important to note. Mostly because if we're talking about military craft or light support systems, it's heavier. Some of the research crafts, not so much, and I've seen some of them around 60%, give or take, on their first orbit, because most of them do multiple orbits and try to get multiple heights. And this is Craig Bennett, the founder and owner of TechViews and Up, and unfortunately I didn't get into all the small stuff in Kerbal Space Program, which would have been different than what we would experience in real life. So unfortunately I wasn't able to expand upon that because this video is more pertaining to real life stuff. But if you want me to get into the Kerbal Space Program side and how to make a good launch in a gravity turn in Kerbal Space Program, then let me know in the comment section, or send me an email by techreviewsandup.com or the YouTube, or you can simply send me an email by Steam by CRUA9. And again, this has been Craig Bennett, and I hope you have a great day.